Good morning, all. Am I audible? Am I audible? Okay, then, all right. So, today we will discuss about next segment of this classes, that is alcohols, phenols, and ethers chapter. So, quick revision will be there for this one: alcohol, phenols, and which one here? Ethers. So, first we will start from alcohol section. In alcohol, directly I am starting from its preparation part. Preparation of alcohol. So again, that same way like we started in previous case. So whenever we will talk about their preparation, screen visible to everyone? Screen visible? No. Visible now? Okay, then, all right. So now first preparation from alkene. First preparation is from which one? Alkene, by addition of water. By addition of water. By addition of which one? Water. So water can be added on alkene in two ways. First one is, I can say that acid catalyzed hydration, and second one is hydroboration oxidation. So two ways are there for the preparation of alcohol from alkene. First one is what? Acid catalyzed hydration, and second one is hydroboration oxidation. This will give us good yield, या best yield I can say, good yield of the product. So among these, which one will give you good yield? Hydroboration oxidation. So what I am saying in this one now, first we will start this section, acid catalyzed hydration. Again, this is similar to that previous case, that this is a type of electrophilic addition reaction via carbocation. Via carbocation. Now this one, addition of water according to anti-Markovnikov rule. Addition of water according to which rule? Anti-Markovnikov rule. In this case, I can say that no carbocation formation. No carbocation formation. So no possibility of rearrangement. No possibility of which one? Rearrangement. Now first, let's say how we are getting product here. First case, we are having here this alkene. CH3CH double bond CH2, and here I wrote like this, H2O H plus. What I said here, H2O H plus, or maybe I can use here like this also, dilute H2SO4. Maybe I can use here which one also? Dilute H2SO4. So in this case, our electrophilic part is which one? H plus ion, or nucleophile will be here which one? H2O. Electrophile will be which one here? H plus ion, or nucleophile will be which one here? H2O. So what you will get here product? What will be the product for this one? Finally, product will be for this one is CH3, CH, CH3, and here will be which one? OH. Remember or not this one? Remember everyone, yes or no? Remember, yes or no? Clear hai na? So what I am saying, in this case, how we are getting this product. So basically what we have to do, these are the actual things, but we can remember like that here positive part we have to add here which one? H plus ion, or negative part we have to add here which one ion? OH minus ion. Negative part will be which one here? H plus OH minus ion, and positive part will be which one here? H plus ion. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next, if I said here this question, tell me now, and I'm writing now like this. What will be the product of this one? What will be the product of this one? What will be the product? Bolo bete. So in this case, first what we have to do? Carbocation formation or not? So carbocation formation will be here more stable or not? Clear? So this carbocation will be more stable or not? After this one, what you will get? Negative part will add it to this one or not? And that is which one here? OH or not? Which one here? OH or not? Clear? Yes or no? Clear to everyone? Yes or no? So this will be the product. Why this is not correct? Why this is not correct, everyone? Because in this case, first this carbocation will undergo for rearrangement or not? Rearrangement there or not there? Yes or no? So now after rearrangement, finally you will get product will be this or not. Any confusion in this one? So difference is what? In this case, first carbocation formation and carbocation formation with respect to this double bond, and that carbon will convert it to carbocation, which is comparatively more stable. Second step, what we have to check? Rearrangement. If there, then do it. And last step, we have to attach there which one? OH minus. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now, next part will be what here? Hydroboration oxidation. Hydroboration oxidation. So in this case, total two parts are there. Yeah, two steps are there. First one is hydroboration. For hydroboration, we will use diborane. This is only for which one? Hydroboration. Now second step is which one? Oxidation. And for oxidation, we are using here H2O2 along with NaOH, a basic medium. Now this is called as which one? Oxidation. So two things are there. First of them is which one? Hydroboration, and second one is which one? Oxidation. And remember in exam time, check whether this segment is given or not. If this is not given, then product will be as per only which one? Hydroboration. Means if I said like this, let's say I'm having this one here again, CH3CH double bond CH2, and this is reacting with diborane. Diborane means what? Dimer of BH3 or not? Diborane means what? Dimer of BH3 or not? Diborane means what? Dimer of BH3 or not? So in this reaction, if you remember, directly we was writing like this. I'm not discussing its mechanism here. First will be this compound or not. Clear? Now, this will further continue till all hydrogen of this boron is not replaced by alkyl group. Check. Now this is called as a tri-alkyl borane. Clear to everyone? Yes or no? This is called as which one? Tri-alkyl borane. Now this tri-alkyl borane undergo for which one? Oxidation. Now this tri-alkyl borane undergo for which one? Oxidation. After oxidation, this bond will break. Yeah, better I'm saying here like this. Like that. This is suppose I said here R. So this also R here, and this also which one here? R. Clear to everyone or not? So this bond will break. This side what we will get? OH. And this side also what we will get here? OH. Both side what we have to attach here? OH. So here you will get how many moles of alcohol? How many moles of alcohol? 3. And side product will be here which one? Boric acid. Side product will be which one here? Boric acid. Side product will be which one here? Boric acid. Clear to everyone? Yes or no? So what simply I am saying, first check whether this is complete hydroboration oxidation, yeah, only which one? Hydroboration. If here only hydroboration will be there, then reaction will stop at which one? Tri-alkyl borane part. Or if oxidation also proceed, then this tri-alkyl borane converted into which one? Alcohol product. And parallelly we will get here one side product also, that is which one? Boric acid. That is which one here? Boric acid. Now tell me one thing. This alkene we started, and finally this alcohol we are getting. Now check these two. This is addition of water, this is addition of water, this is addition of water as per which rule? As per which rule? Anti-Markovnikov rule. Is that clear to everyone? Yes or no? So what I'm saying in this one, that simply check first whether this is hydroboration oxidation or not, and if this is hydroboration oxidation, then I can say that two steps are going on. First step will be reaction with only diborane, and we will get one of the product here. Which one? Trialkyl borane, and this trialkyl borane after the reaction with oxidizing agent converted to boric acid and alcohol will form as per which rule here? Anti-Markovnikov rule. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next, if I said here this question, and I said first here B2H6 THF, and second I said here H2O2, let's say OH minus. Finally, product of the reaction, product of the reaction, product of the reaction, product of the reaction. Which side will be H? Which side will be OH? Which side will be H? Which side will be OH? Is it? Is it? Tell me yes or no. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next preparation will be from carbonyl compound. From which compound? Carbonyl compound. From which compound? Carbonyl compound. ये better I'm saying here, by reduction I'm saying. By reduction. Second preparation will be which one? By reduction. Reduction. Here I'm writing first reducing agent LiAlH4. Strong reducing agent, hydride donor. Strong reducing agent, hydride donor, expensive reagent. Strong reducing agent, and then this is also which one? Hydride donor and expensive agent. Second one, what I am saying here? NaBH4. This is comparatively weak reducing agent. What I said here? Comparatively weak reducing agent. This is also hydride donor. This is also which one? Hydride donor. Now third you will get here catalytic reduction. Third you will get here which one? Catalytic reduction. Catalytic reduction means what? H2 with either nickel, either PT, or either which one? PD. So these are the most widely used reducing agent. First one, LiAlH4. Yeah, let's say I'm writing here like this. Let's say we are having here this side aldehyde, ketone, carboxylic acid, acid chloride, ester, and last I can say here sufficient. Aldehyde, acid chloride, carboxylic acid, and then which one will be here? Ester. Now, if suppose we are having this side LiAlH4. So here LiAlH4 can reduce any one of them. LiAlH4 can reduce any one of them, and all of them converted to which one? Alcohol, depending on the case to case. NaBH4 can reduce aldehyde, ketone, and acid chloride, and rest of them no. If I said here which one? H2PT. Which one I said here? H2PT. Yeah, better that I'll discuss separately. These three I'm saying, or two I'm saying first here. Which one? One of them is which one here? Aldehyde, ketone, carboxylic acid, aldehyde, and acid chloride and ester. These can be reduced by LiAlH4. Even can also be reduced by which one? Can also be reduced by which one? NaBH4, except which case? Carboxylic acid and ester. अब देखो इधर. First one, if I said aldehyde. Second, I said ketone. Third, I said carboxylic acid. Fourth, acid chloride. Simple, I'm saying these four. Now reduction means what? Reduction means what? I can say addition of hydrogen or not. Reduction means what? Addition of hydrogen or not. Acid anhydride can also be reduced. That can also be reduced. Acid anhydride can also be reduced. So here addition of hydrogen means what? This converted to CH2OH. This converted to CH2OH. Next also converted, but this time both side we will get here which degree of alcohol? 2 degree. Now tell me one thing. If I directly added here hydrogen, then this also OH and this also OH. Yes or no? So here I can say like that. This is not a perfect way to write the mechanism, but you can remember like this. Is it yes or no? Can I say like this? Yes or no? Can I say like this? Yes or no? But this again unstable. So from this one, which one we have to remove here? H2 molecule. So basically this again converted to which one? Aldehyde, and aldehyde further reduced to which one? 1 degree alcohol or not? So final product of the reaction will be which one here? Final product of the reaction will be which one here? 1 degree alcohol. Check karo, yes or no? Final product of the reaction will be which one here? 1 degree alcohol. Again I am saying this is not a mechanism of this one. Now next, same way here. In this case, first this Cl will be removed, and then you will get this product, and finally you will get here which product? RCH2OH. RCH2OH. Clear to everyone? Yes or no? Clear to everyone? Yes or no? So what I am saying here, simple things are there, that aldehyde directly converted to 1 degree alcohol, ketone directly converted to 2 degree alcohol, carboxylic acid directly converted to 1 degree alcohol, acid chloride directly converted to 1 degree alcohol. Clear to everyone? Yes or no? Now, first one what we can use here? In first case, which reducing agent we can use? We can use lithium aluminum hydride, or we can also use sodium borohydride. We can also use which one also? Sodium borohydride, NaBH4. Now next, here also lithium aluminum hydride and sodium borohydride. Clear to everyone? Yes or no? Next only we can use here LiAlH4. Last again we can use here LiAlH4, and which one also? Yeah, or which one also we can use here? NaBH4. Clear to everyone? Yes or no? Now carboxylic acid can also reduces selectively by diborane and converted to 1 degree alcohol. What I said here? Carboxylic acid can selectively reduces by which one? Diborane, to convert it into how much degree of alcohol? 1 degree of alcohol. Which one I said here? Carboxylic acid. Which one I said here again? Carboxylic acid. Now remember one thing. Commercially carboxylic acid reduces by catalytic hydrogenation, but first converted to ester, and then reduce by catalytic hydrogenation, that is which one? H2 and PT. Clear to everyone? Yes or no? What I am saying here, commercially, if suppose someone said that how carboxylic acid reduces, then we have a two choice for carboxylic acid. Either we can use LiAlH4, or either we can use which one also? Ester cannot reduces by NaBH4. No, ester cannot be reduces by NaBH4. Clear hai? Yes or no? Now next by Grignard reagent. Next is which one? By which reagent? Grignard reagent. By which reagent here? Grignard reagent. So Grignard reagent means what? Let's say we are having one of the aldehyde here, and this aldehyde react with Grignard reagent. Let's say we are having here which one? CH3MgCl. Which Grignard reagent we are having here? CH3MgCl. Now this CH3MgCl attack on this one or not? And you will get first adduct formation. This is OMgX H, and this side will be CH3, which is known as which compound here? Adduct. Which is known as which compound here? Adduct. Now this adduct undergoes for hydrolysis. This adduct undergoes for which one? Hydrolysis, and directly this will convert it to OH, and this will be CH3. So this become how much degree of alcohol here? How much degree of alcohol here? How much degree of alcohol here? 2 degree of alcohol. So make it simple, this one. Let's say we are having here which one? Let's say we are having here aldehyde. Aldehyde reacts with Grignard reagent followed by hydrolysis. Then you will get a 2 degree alcohol. If we are having ketone reacting with Grignard reagent followed by hydrolysis, then you will get how much degree of alcohol? 3 degree of alcohol. Clear to everyone, yes or no? So these are the preparations of which one here? Alcohol. These are the preparations of which one here? Alcohol. Clear to everyone, yes or no? So simple. How many ways are there for the preparation of alcohol? First way was by addition of water on alkene, and addition of water on alkene proceeds in total how many ways? 2 ways. First way was acid catalyzed hydration, and second way was which one? Hydroboration oxidation. Now next we started which one here? By reduction of carbonyl compound. Clear to everyone, yes or no? Now after this one we will start chemical properties of alcohol. Chemical properties. Chemical properties of which one here? Alcohol. So everyone this side. Alcohols means what? ROH group. So in alcohol you found 2 types of reaction due to breaking of OH bond, or this side due to breaking of carbon oxygen bond. How many types of reactions shown by this one? 2 types. Either maybe due to breaking of OH bond, or either maybe due to breaking of which bond? CO bond. Clear, yes or no? Now first example, let's say I said here ROH reacted with, let's say, sodium metal. ROH reacted with which metal? Sodium metal. Everyone knows that sodium is a metal, so basic in nature. And this OH bond means what? This hydrogen is acidic in nature or not? I'm not saying that this will be strong acid or weak acid, but this hydrogen is acidic in nature or not? So if this is acidic in nature, now this will react with this one and you will get RONA and evolve which gas? H2 gas. And evolve which gas here again? H2 gas. Now next, if I said, let's say this one, ROH reacting with, let's say last class only, SOCl2, then what you will get here? RCl plus SO2 plus which one here? HCl. क्या चल रहा है ये? Now visible? So in this case, which bond we break in first case? In first case we break which bond here? OH bond. In second case we break here which bond here? Carbon oxygen bond. So in general, if there will be a breaking of OH bond, then in general this is its which nature? Nucleophilic. And here if this is breaking carbon oxygen bond, then alcohol acting as a which one? Electrophilic in nature. Clear to everyone, yes or no? Audible? So now everyone this side. So first, a brief discussion about acid-base reaction. So in acid-base reaction, if you remember one statement that strong react to give weak. What I said here, strong react to give which one? Weak. Means what? Reacting acid should be strong or formed acid should be strong. Reacting acid should be which one? Strong. Let's say I'm having here simple order of acidic strength. I can say first which acid? Sulfonic acid. Then I can say in general which acid? Picric acid first I can say better. And then I can say which acid here? Carboxylic acid. And then I can use here which one also? Carbonic acid. Then you found here phenol, alcohol. Yeah, before that water is also there. Before that water is also. Alcohol. Then you found here ammonia. And then last you found here I can say alkane, or last even I can say which one also? H2. So if I said methanol, yes, let's say any one of the alcohol we are having, this alcohol can react with sodium metal. Answer me. If this is reacting with this sodium metal, then this H2 gas evolve or not? And this side alcohol reacting and formed as which one here? H2 or not? So giving which one here? Weak or not? Alcohols are more acidic than H2 or not? So this reaction possible or not possible? Possible. If I said next here, let's say NaOH. Let's say I said which one here? NaOH. When NaOH react with this one, then what we will expect here as a product? C2H5ONa plus which one? H2O. Now tell me, H2O or alcohol, which one is more acidic? H2O is more acidic. That is why this reaction possible or not possible. Now next, if I said here, let's say NH2 minus. Now tell me, NH2 minus will give you which compound here? NH3. Now NH3 is more acidic or less acidic? Less acidic. So that is why this possible or not possible? Possible or not possible? Now similarly, if this side I'm having phenol. Similarly, this side what I'm having here, which one? Phenol. Now phenol, if reacting with let's say sodium metal. So you will get again which gas here? H2 plus sodium phenoxide or not? H2 plus which one? Sodium phenoxide. So reaction possible or not possible? Reaction possible or not possible? Now next, if I said here, let's say again NaOH. What I said here, which one? NaOH. Tell me now, when this will react, then what you will get here? One of them is H2O and one of them is a phenoxide or not? One of them is H2O and one of them is phenoxide or not? Again, tell me now, water or phenol, which one is more acidic? Water or phenol, which one is more acidic? Phenol. So again, this reaction possible. But if I said sodium bicarbonate, NaHCO3, if I said which one? Sodium bicarbonate. Now tell me, in this case, reaction possible or not possible? In this case, reaction not possible. Why not possible? Because in this case, we will get which acid? Carbonic acid, and carbonic acid is stronger acid than which one? Phenol. So possible or not possible again? Not possible. Let's say I said here one more, I'm saying NH2 minus. Now tell me this reaction possible or not possible? Here again reaction possible. Here you will get which one? Ammonia. Clear to everyone, yes or no? So this is first case where we are discussing about which one? Acid-base reaction. And in acid-base reaction, what we need to check that is reacting acid should be stronger than which acid? Weak acid. And check in all of the cases which type of bond in alcohol is breaking. OH bond. Check karo yes or no. Which bond in alcohol break here? OH bond. Which bond in alcohol break here? OH bond. And last, if they ask here, rate of these acid-base reaction, rate of these acid-base reaction is directly proportional to their acidic strength. is directly proportional to their which one? Acidic strength. Means if I said 1 degree, 2 degree and 3 degree alcohol, 1 degree, 2 degree and 3 degree alcohol, which one is most acidic among these? 1 degree, which one is the least acidic among these? 3 degree. So now here order of rate of reaction will be which one? 1 degree, then 2 degree and then 3 degree. And if I said that alcohol and phenol, which one is more reactive? Alcohols and phenol, which one is more reactive? Then answer will be which one? Phenol is more reactive than alcohol towards acid-base reaction. Reason? Because of its acidic strength. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now, next part here. Next part is here which one? Esterification. Next part is which one here? Esterification. Esterification means what? Formation of ester. Esterification means what? Which one here? Formation of ester. So formation of ester in general proceeds in two medium. Proceeds in how many medium? Two. One of them acidic and one of them in which medium? Basic. So in general, how many mediums are there for the ester formation? One of them is acidic and one of them is which one? Basic. Basic medium is acid chloride reacting with alcohol, and to provide basic medium, here we are adding one of the base which is named as which one? Pyridine. And now this side you will get product. Let's say this is R dash. Product will be which one? RCOO R dash plus side product will be which one here? HCl. Now, why this reaction required basic medium? Everyone, here side product that will be which one here? HCl. And HCl, you all of know that HCl can react with which one? Alcohol. And if HCl start reacting with alcohol, then some of the amount of this alcohol combined with HCl, therefore this alcohol can combine with acid chloride in less amount or not? Yes or no? And if this is reacting with a less amount with this acid chloride, then yield of this ester will be more or less? Less yield. So to increase this yield, what we need to do? We need to prevent reaction of this HCl with alcohol, and to prevent this reaction of HCl with alcohol, we neutralize this HCl by the adding of pyridine. What I said here? What we did here? What we did here? We added here pyridine so that this HCl acid can be neutralized. What I said, this HCl acid can be neutralized. If this neutralized, then I can say that this reaction is not going through. That's why this most of the alcohol combined with acid chloride and most of the acid chloride converted into which one? Ester. Clear to everyone? Yes or no? Now, this is in which medium here? Basic medium. Now, acidic medium, acid chloride, carboxylic acid plus alcohol. Next I can say here acid anhydride plus which one here? Alcohol. R1 I'm saying here. Clear to everyone? Yes or no? So what is difference here? So we are having total how many ways here? We are having total two ways. One of them in which acidic medium and one of them in which medium? Basic medium. Clear to everyone? Yes or no? In this case, how to write down that product? From this side, what we have to remove? OH, and from this side, what we have to remove? H. Similarly, in this case, what we have to remove? This section I can say, and this section from which one we have to remove here? H. Means one thing is very clear. Whenever there will be a formation of ester, check. One side alcohol is fixed. One side, what is fixed here? Alcohol. And alcohol always use its which part? Hydrogen part. Alcohol use always its which part? Hydrogen part. Remaining, if carboxylic acid, then OH, acid chloride, then Cl, and anhydride, then we have to remove one unit. Clear to everyone? Yes or no? Now tell me one thing here. So in first case, product will be which one here? R, C, double bond O, R1 plus what will be there here? H2O. Now, In acidic medium, these two reactions are reversible or not? In acidic medium, these two reactions are reversible or not? And if these are reversible, then we can apply here Le-Chatelier principle and we can shift this equilibrium in forward direction so that we will get maximum yield of, which one? Ester. Clear to everyone or not? How? By removal of water. What I said here, which one? By removal of water, this equilibrium shift in which direction? Forward direction. Equilibrium shift in which direction? Forward direction. Clear to everyone or not? Now last one thing. Here medium is acidic. So generally acidic medium we will be provided by H2SO4, and what we are using here, which one? H plus ion. In last case, what will be the product? Here R C double bond O R dash plus another product will be here carboxylic acid. Another product will be which one here? Carboxylic acid. So total how many ways are there for the formation of ester? If you check here, total 3 ways are there. Out of 3 ways, 2 ways are in acidic medium and 1 way in which medium? Basic medium. In acidic medium, we are having carboxylic acid plus alcohol and acid anhydride plus alcohol, while in basic medium we are having acid chloride plus which one here? Alcohol. Now in NCERT here one question is given that if I'm having this compound, what is the name of this compound? What is the name of this compound? Tell me. What is name of this compound? Salicylic acid. Clear. What is name of this compound here? Salicylic acid. What is name of this compound? Salicylic acid. And now this salicylic acid reacting with acid anhydride or not? Now tell me one thing. In this case, how this reaction will proceed? So this is ester formation or not? One side acid anhydride and one side we are having OH, but problem is what? That how to identify reaction will be there. Here this side we are having acid anhydride. And for ester formation, one side we need alcohol, one side what we need? Alcohol, and another side may be either carboxylic, either anhydride, or either which one? Acid chloride. So here one side what we are having? Acid anhydride. So this side, which part we have to remove from this one? Alcohol, and here instead of alcohol what we are having here? Phenol. So now product of this reaction will be which one here? Is it? Yes or no? This is known as acetyl salicylic acid. What I said this name? Acetyl salicylic acid, or it's one of the common name which is also known as aspirin. One of the common name which is also known as which one here? Aspirin. Clear to everyone? Yes or no? Clear to everyone? Yes or no? So either there maybe will be which one? Formation of aspirin, or either I can say this is which one? Acetyl salicylic acid. Clear to everyone? Yes or no? Now next section is reaction due to breaking of which bond? Reaction due to breaking of which bond? CO bond. Reaction due to breaking of which bond? CO bond. Again, reaction due to breaking of which bond here? CO bond. Reaction due to breaking of which bond? CO bond. Here first is reaction with HX. Reaction with which one here? HX. And specifically here we will discuss concentrated HCl. Concentrated HCl mixed with which one? ZnCl2, which is named as Lucas reagent. This reaction even we discuss in haloalkanes also, which is named as which reagent here? Lucas reagent. Now directly I am writing here order of rate of reaction. Order of rate of reaction will be here which one? 3 degree, 2 degree, and then which one? 1 degree. What I said indirectly. If alcohol react with concentrated HCl along with ZnCl2, then can I say directly product will be this or not? RCl. So here OH substituted by which one? Cl or not? OH substituted by which one? Cl. So if OH substituted by Cl, then this may be either SN1 or this may be either SN2. This may be either SN1 or maybe either which one? SN2. What? Okay. They are playing with the screen now. Now visible? Very good, very good. These classes are for you and you are playing here. Yes. So in this case, OH replaces by Cl or not. So if this OH replaces by Cl, then this may be either SN1 or this may be either which one? SN2. This may be either which one? SN1 or maybe either which one? SN2. So in this case, if I said this rate of reaction we found, then probably this following which mechanism here? In general, can I say SN1 mechanism or not? And SN1 mechanism rate, if you remember, directly proportional to stability of which one? Carbocation. Stability of which one? Carbocation. Clear to everyone, yes or no? So in this reaction I can summarize this thing simply that in this case when reaction is going on alcohol, then alcohol 3 degree, 2 degree and 1 degree are possible. So which alcohol is starting first reacting? 3 degree, then which one? 2 degree, and then which one? 1 degree. देखो इधर now here one condition is also there that this alcohol should be soluble, this alcohol should be soluble in Lucas reagent, and the formed alkyl chloride is insoluble, and the formed alkyl chloride is which one here? Insoluble. That is why if let's say we are having initially in this case some alcohol is present, and when we added here which reagent? Lucas reagent, then initially they were having one clear solution or not, but after the reaction here you will get two layers. One of the layer belongs to alkyl chloride, and one of the layer belongs to which one? Lucas reagent alcohol. So that here I can say two things are possible. One of them is either you can use word turbidity, or either we can say another word which is also named as layer separation. One of the word will be which one here? Turbidity, and another word will be which one here? Layer separation. So in which case this turbidity, layer separation will be fastest 3 degree, then 2 degree, and then 1 degree. Means this reaction also used to distinguish 1 degree, 2 degree and 3 degree alcohol. Some additional statements maybe you found that in case of 3 degree alcohol this turbidity you found suddenly, but in case of 2 degree around it will take around how many minutes? Around I'm saying roughly 5 minutes max to max. And 1 degree, so many points are there. Maybe you can say that in 1 degree no turbidity. Maybe I can say that 1 degree maybe will give you turbidity but after long time. Or maybe you found that in case of 1 degree turbidity may also appear but after some heating. Maybe so many possibilities are there, but remember in case of 1 degree it will take long time. Maybe you will get turbidity after heating. Maybe I can say that almost no turbidity. Maybe almost I can say that here almost no turbidity. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next after this one what will be there? After this one next is dehydration of alcohol. What you wrote near 3 degree. This is suddenly. Next will be which one here? Dehydration of alcohol. Dehydration of alcohol means removal of water. And for dehydration of alcohol in general we requires dehydrating agent. What we need here? Dehydrating agent. And this is a type of which reaction? Elimination reaction. Type of which reaction? This one, elimination reaction. For elimination maybe either E1 or maybe either which one? E2. Depending on the condition whether which dehydrating agent we are using. And if you remember, dehydration means what? Elimination, and elimination means what? Fastest will be in 3 degree, then 2 degree, and then which one? 1 degree. So which alcohol will dehydrate first? 3 degree, and then which one will dehydrate? 2 degree, and then which one will be there? 1 degree. In general, alcohols E1 means what? Most of the time either you found concentrated H2SO4, maybe you found either which one here? H3PO4. And if suppose this is E2, then here maybe you found Al2O3, or maybe you found here anhydrous ZnCl2. Clear to everyone? Yes or no? Al2O3, or maybe that will be either which one? Anhydrous ZnCl2. This is the preferred way I'm saying, but most of the time this is we need to proceed here if this is in E1 case means what? That may be either which one? Concentrated H2SO4 and concentrated H3PO4. For example, if I said this one and here I said concentrated H2SO4, tell me now what will be the product here. So what we have to do first? This OH will get protonate and remove as a leaving group or not. Now this is your carbocation formation. Now this carbocation formation will convert it to alkene. How many alkenes are there here? 2. Yes or no? How many alkenes are there here? 2. But if I said in this case, which one will be major, which one will be minor? Which one will be major, which one will be minor? Tell me which one will be major, which one will be minor? Second one will be major and first one will be which one? Minor. And one more question. Here if I said in this case total number of product. In this case total number of product. In this case total number of product. How many will be there? 3 or not? How many will be there? 3. Why 3? Because in this case we will get a geometrical isomers, that is one of them cis and one of them which one? Trans. One of them cis and one of them which one here? Trans. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next after this one, if I said this question here, now tell me H plus ion heat, what will be the product for this reaction? What will be the product for this reaction? What will be the product for this reaction? So in this case, first there will be a carbocation formation or not? If there will be a carbocation formation, then you will get this thing or not? Again, there will be a possibility of rearrangement, then we can say this is 1,2 hydride shift or not? After 1,2 hydride shift, what we will get here? Is this carbocation or not? Now this carbocation undergoes for dehydration and you will get here one of the major and one of the minor. Major will be which one here? First, and minor will be which one here? Second. So this is which product here? Major, and this is here which product? Minor. Now tell me among these 2 alkene, here is there any alkene which can show geometrical isomerism? Check, is there any alkene which can show here geometrical isomerism? So none of the alkene here geometrically active. Here also CH3. In this case H and H. So total number of product, how many will be there here? 2. How many total product will be there here? 2. But which one will be more stable? First, that is why this will become major, and second become which one? Minor. Now next after this one, oxidation of alcohol. Oxidation of alcohol. Oxidation of which one? Alcohol. Oxidation of which one? Alcohol. So first, let's say I'm having here 1 degree alcohol, RCH2OH. As per you, what is meaning by oxidation? Oxidation meaning by, either I can define this in one way, first one removal of hydrogen, or second I can say addition of oxygen. So if I remove hydrogen, one from that carbon to which OH attach and one of them from which one? OH, then what you will get here? RCH double bond O plus what will be there here? H2. Can I say like this or not? Can I say like this or not? Now second, if I'm writing this one, OH. Now this was 1 degree, this is 2 degrees. So from this side H, this side which one? H. What you will get now this side? R, C double bond O, R again plus which one? H2. If I said 3 degree alcohol, now tell me in 3 degree alcohol, oxidation possible or not possible? Why not possible? Probably clear to everyone or not? Because of the absence of hydrogen on this carbon which is directly connected to which one? OH. So in this case directly I can say that no oxidation. What I can say in this case? No oxidation. Any confusion till here? Any confusion till here? Now these can further also oxidize or not? If aldehyde further oxidize, now this will convert it to which one? Carboxylic acid. Now what we are doing here? Addition of oxygen. Now what we are doing here? Which one? Addition of oxygen. But if you remember, ketones under normal condition. What I am saying here? Under which condition? Normal condition. What I can say here? Almost no oxidation. Clear to everyone or not? So under which condition I said this is normal condition, oxidation possible or not possible here? Not possible. So two things are there. 1 degree alcohol first oxidize to aldehyde, then further oxidize to carboxylic acid. 2 degree alcohol under normal condition can only oxidize to ketone, while 3 degree alcohol no oxidation. What I said here, 3 degree alcohol no oxidation. Now everyone, if we are having strong oxidizing agent, what I said here, strong oxidizing agent, then 1 degree alcohol directly converted to carboxylic acid. Or if we are having mild oxidizing agent, then 1 degree alcohol converted to which one? Alcohol. Sorry, 1 degree alcohol converted to which one? Aldehyde. If we are having 2 degree alcohol, either you can use strong or either you can use mild. In both cases, this will oxidize to ketone. Either we are having mild or either we are having which one? Strong. Then in both cases, this will convert it to which one? This will convert it to which one? Ketone. Now target will be, you need to remember some of the strong oxidizing agent and mild oxidizing agent as per our syllabus. I'm writing them. Dekho idhar. So strong oxidizing agent. Strong oxidizing agent. First, KMnO4, either in acidic or in which medium? Basic medium. Either I can say K2Cr2O7 only in which medium? Acidic. Either I can say CrO3 plus which one? H2O. Either I can say H2CrO4, which is named as a chromic acid. Or last I can say here CrO3 plus H2O plus CrO3 plus H2O plus which one? CrO3 plus H2O plus concentrated H2SO4. CrO3 plus H2O plus which one? Yeah, better I'm saying this one like this. CrO3 plus concentrated H2SO4 plus acetone, which is named as Jones reagent. Which is named as which reagent here? Jones reagent. Now this side, mild oxidizing agent. Mild oxidizing agent. First I can say here PCC. PCC means what? Pyridinium chlorochromate. I'm not writing now their complete name. Next, what I'm saying here? PDC. One of them I can say which one here? PCC. One of them I can say which one here? PDC. Clear hai na? Even I can say here CrO3. CrO3 plus CH2Cl2 plus which one here? Acetone. What I said here? CrO3 plus CH2Cl2 plus which one here? Acetone. Sorry, not acetone. This is pyridine. Plus which one? Pyridine. These are which type of agent here? Mild oxidizing. This is pyridinium dichlorochromate, similar to PCC. And here which one is preferred? Which one is preferred? Remember na that one? Which one is preferred here? PCC. Which one is preferred here? PCC. Now everyone this side. Dekho that. I'm writing here one more thing. When vapor of alcohol passed over copper metal. What I said here, when vapor of alcohol passed over which one? Copper metal, then this also oxidize 1 degree to aldehyde and 2 degree to ketone. And remember, here copper is acting as a catalyst. Copper is not acting as a here, I can say that oxidizing agent. Copper is acting as a which one here? Catalyst. Clear to everyone? Yes or no? Any confusion till here? Now remember one thing. When 3 degree alcohol, what I said here, when 3 degree alcohol, how much degree alcohol? When 3 degree alcohol reacts with copper and temperature, how much was there? Temperature, how much was there? 573 Kelvin, then dehydration take place. What will take place here? Dehydration take place. In which case I said here? In which case I said this one is in which degree? 3 degree. Clear to everyone, yes or no? Clear to everyone, yes or no? Done. Now this is all about here first section, that is which one here? Alcohol. Which section I said this is? Alcohol. Now next will be, I'm starting here, phenol section. Phenol section, clear to everyone, yes or no? Some commercial alcohols are there in between them, you can read that by NCERT. Phenol section. So in phenol, if I said first, total how many preparations are given in NCERT? You found total 4 preparations. First one, let's say we are having benzene, and this benzene, ये better I can say aniline, I can say benzene diazonium chloride I'm using here. Benzene diazonium chloride with warm water converted to which one directly? Phenol. Second I can say here chlorobenzene. Chlorobenzene reacted with aqueous NaOH. Temperature was 623 Kelvin. Pressure was 300 atm. Remember this thing or not? So in this case, directly you will get a phenol. But if you remember, phenol, today only we discussed, can react with NaOH. Therefore, instead of phenol, directly we will get here phenoxide ion, which after acidification converted to phenol. Clear, yes or no? Now, if I use here benzene sulfonic acid, what I use here, benzene sulfonic acid, this is also reacting with NaOH. Now here, same thing, first you will get a phenoxide ion, and then after acidification, this will convert it to which one again? Phenol. Last, from cumene, industrial preparation, that is very important here, yes or no? What is the name of this compound? Cumene isopropyl benzene. In this case, what we are using here? O2H nu. Remember or not this thing? What we are using here first? What we are using here first? What we are using here first? O2H nu, yes or no? O2H nu you can use. O2H nu, or either you can say that air. Atmospheric air we can also use. First you will get cumene hydroperoxide, which finally converted to which one? Phenol after hydrolysis, and side product here will be which one? Acetone. Side product will be which one here? Acetone. From this reaction, lot of question asked in our paper. First one here, which is the side product? Acetone. And you found one line regarding this one, that acetone also formed in large quantity in this one. Acetone also formed in which quantity? Large quantity. Second thing, what is intermediate here? So intermediate is which one here? Cumene hydroperoxide. Clear to everyone, yes or no? Now, chemical properties. Chemical properties. Chemical properties. First, I'm discussing one of the topic, oxidation of phenol. Oxidation of phenol. What I said first here, oxidation of phenol. First thing, if we are talking about oxidation of benzene, then benzene is very difficult to oxidize. I'm not saying that not possible to oxidize. Benzene possible to oxidize, but somehow this is difficult to oxidize. So how benzene derivatives, how oxidation of benzene can be converted to easy oxidation, this is in general done by those groups which are strongly activating, such as which one? OH. Means those benzene rings which are activating rings, they can easily oxidize, and those which are less activating, they are difficult to oxidize. So when phenol coming in contact with which one? Na2Cr2O7 in which medium? Acidic medium. Or here I can also use atmospheric air also. What I said here, what we can also use here, atmospheric air. In both cases, phenol can be oxidized. What I said here, in both cases, phenol can be oxidized. But remember, along with this one, this is slow oxidation. What I said here, this one, slow oxidation. Here we can use in place of Na2Cr2O7, chromic acid can also be used. What can also be used? Chromic acid, and in this case you will get this product which is named as parabenzoquinone or conjugated diketone, or conjugated which one? Diketone. So two things are there, that may be either which one? Parabenzoquinone, or maybe either which one? Conjugated diketone, and this is a colored compound. Which type of compound this one? Colored compound. So you found one question in NCERT that phenol become dark when this exposed to air. Reason? Because of its oxidation, this converted to which one? Conjugated diketone. Clear to everyone? Yes or no? Now, next thing. If we are having here phenol now. Phenol having which group? OH group. OH group is plus M or minus M? Plus M. If this is plus M, or either I can say plus R, so this becomes strong activating group or not? This become which one? Strong activating. And strong activating are which type group? Either ortho or either which directive? Para directive. So here phenol means what? OH allowed incoming electrophile attached to either ortho position or either to which position? Para position. Now everyone this side. So this is now phenol. Let's say first I'm talking about nitration. What I said about which one? Nitration. Now for nitration, if you remember till now, we use mostly concentrated nitric acid plus which one? H2SO4, nitrating mixture which is concentrated H2SO4 plus. So in this case, if I'm using here instead of this one, this thing, dilute nitric acid, then here you will get two products. One of them orthonitrophenol and one of them paranitrophenol. How many products I said here? Two. One of them orthonitrophenol and one of them which one? Paranitrophenol. And here which one will be major? Ortho will be major. And you remember that here in this case, this is having high boiling point or not? Which one having high boiling point here? Para. Why para having high boiling point? Due to intermolecular hydrogen bonding. Therefore, orthonitrophenol and paranitrophenol can be separated from their mixture by which process? Steam distillation. Line of NCERT, even PYQ question. If I use here concentrated nitric acid, what I use here? Concentrated nitric acid. Then in this case, concentration of electrophile also more. So here instead of mono substitution, you will get here picric acid. What you will get here? Which one? Picric acid plus what I am writing here, everyone this side. Concentrated nitric acid is a strong oxidizing agent also, which oxidize this phenol to which one? Oxidized product. Phenol this into which one? Which product? Oxidized product. And now if this phenol converted to picric acid or parallel phenol converted to oxidized product, then can I say in this case yield of this picric acid will be low? What I said here, yield will be less or not? Yield is less or not? Why this yield is less? Why this yield is less? Because in this case this phenol also oxidized. Complete phenol is not converted to which one here? Picric acid. So now, if I need to increase yield of this picric acid, then what we have to do? We have to prevent the formation of We have to prevent the formation of which product here? Oxidized product. Now tell me one thing. What I said just now, that when benzene oxidation will be easy, when benzene connected to activating group or deactivating group? When benzene connected to which group? Activating group or deactivating group? Activating group. So if I connected here some of the deactivating group, then can I say that oxidation become difficult? So to overcome from this problem, what we are doing here? Sulfonation. What we are doing here? Sulfonation. And how many times we will do here sulfonation? 2 times. So you will get first this product, OH, SO3H, SO3H. Now we can proceed through which one? Concentrated HNO3 followed by which one? Heating. Now this group easy to replace also. This group is easy to displace also. Even this can displace in multiple ways. One of them ways, this can easily displace by heating. This can easily displace by acidic medium also. And now after this one you will get here which product? Clear to everyone, yes or no? Now what is difference? Here if this is, let's say, first reaction and this is second reaction, in which case picric acid will form in better yield. First one or second one? In which case picric acid formed in better yield, first one or second one? Second one. Reason clear or not? Why this is so? Because in second case, due to the formation of this compound, its oxidation become difficult. Now next thing here, if I said halogenation. So halogenation, if you use Br2 along with a non-polar solvent. So non-polar solvent will give you either ortho or either which one? Para. Which one will be major here? Which one will be major here? Para. Now if I use here bromine water, now here which type of solvent we are using? Polar Cortex solvent. So this will give you large quantity of this electrophile. Therefore here you will get this thing, which is in which color? White PPT. Which color this one? White PPT. Clear to everyone, yes or no? Now next after this one. Next if I said here halogenation done, sulfur that nitration done. Now next will be here one of the reaction which is named as Riemer-Tiemann reaction. Which reaction I said here? Riemer-Tiemann reaction. For this one, this side I'm writing. Chloroform plus aqueous and AOH. First these two react and you will get here one electrophile. That electrophile is which one here? Dichlorocarbene. What is electrophile? This one, dichlorocarbene. And now this dichlorocarbene first converted to this one or not? Check out this dichlorocarbene converted to which one? This dichlorocarbene converted to which one? Sorry, this will be ONA. This is intermediate of this reaction, benzyl phenoxide, yes or no? This will be the intermediate reaction or not? Now after this one, if you use here NaOH again, then you will get orthosalicylaldehyde. What you will get as a major product here? Which one? Orthosalicylaldehyde. What we are getting here major product as a orthosalicylaldehyde. Clear, yes or no? Clear, yes or no? Now one last reaction, that is which one here? Col-base. Which one I said here? Col-base. So for col-base what we are using here? We will use here which one? CO2. We will use which one here? CO2. Here CO2 is also acting as a which one? Electrophile. And here you will get directly product salicylic acid. Which one will be the product here? Salicylic acid. Which one will be the product here? Salicylic acid. Clear to everyone, yes or no? Clear to everyone, yes or no? And one last reaction which is left here, that is phenol reaction with zinc. Phenol reaction with which one? Zinc. Phenol reaction with which one? Zinc. So when phenol react with zinc, I'm writing this side. When phenol react with zinc dust, then what you will get here? Benzene plus zinc oxide. What you will get here? Benzene plus which one? Zinc oxide. Done? Yes or no? So in phenol, simply total 4 preparations are there. First one I can say from diazonium salt. Second I can say chlorobenzene. Third I can say again. So third I can say again benzene sulfonic acid. And last I can say which one? That from cumene. From which one? Cumene. Done? Yes or no? Now last section, that is which one here? Ethers. That is which one here? Ethers. First preparation from Williamson's synthesis. Which one I said first? Williamson synthesis. So Williamson synthesis follows which mechanism? Williamson synthesis follows which mechanism here? SN2. Williamson synthesis follows which mechanism here? SN2. So in this case, what we have to do? RO minus alkoxide ion react with alkyl halide and convert it to product, that is which one here? ROR1, which is named as ether. Which is named as which one here? Ether. Which is named as which one here? Ether. Now tell me one thing. Here this is acting as a nucleophile and this is acting as a electrophile. Now, if this is SN2 mechanism, then this become our substrate or not? So which substrate we can use? 1 degree can be used. 2 degrees somehow can be used, but difficult. Here I can say that yield will be less, or 3 degrees strictly we cannot use. So which substrate can be? I can say order of rate of reaction will be which one here? 1 degree, 2 degree, and then which one? 3 degree. Which one we are avoiding here? Yeah, which one we cannot use in this reaction? 3 degree, because in this case, instead of SN2, this prefer to undergo which one? E2. Clear enough? Yes or no? Instead of SN2, this prefer to undergo which one? E2 or not? Instead of SN2, this prefer to undergo which one? E2. So now which one left here? 1 degree, 2 degree, or either I can say we cannot use here this one also. We cannot use here this one also. These cannot be used, yes or no? Reason clear? Why? In this case, partial double bond character. In this case, which character will be there? Partial double bond character, and due to that partial double bond character, this carbon halogen bond easy to break or difficult to break? This carbon halogen bond easy to break or difficult to break? Difficult to break. That is why in this case SN2 reaction is hardly possible, or even I can say that under normal condition not possible. So if I'm using now this question here, CH3O minus reacting with this one. Second, CH3O minus reacting with this one. What is difference in these two reactions? What is difference in these two reactions? First one will be SN2 or not, or second one will be which one here? E2 or not. First one will be which one here? SN2, and second one will be which one here? E2. So in first case, product will be this or not? CH3O. Next, what will be there here? CH2, CH3, and here product will be this one. Clear? Yes or no? If I said like this, now tell me product of this reaction. Product of this reaction. Product of this reaction again. Please don't do yaar stupid. Kya kar rahe ho? Tell me now, in this case, what will be the product? SN2, na this one. Because here only one carbon is there, no beta carbon available here. So product will be this or not. Here, by this reaction, symmetrical and unsymmetrical, both types of ethers can be prepared. Both types of ethers can be prepared. One last, that is a database, that ethanol reacting with concentrated H2SO4, 140 degrees Celsius, 170 degrees Celsius. 140 degrees Celsius, this preferred low temperature means what? SN2, and here product will be which one? C2H5 or C2H5. This is high temperature, so this prefer E2, and here alkene will be the major product. Clear to everyone, yes or no? Here alkene will be the which product here? Major product. Done. Now last chemical properties, only one reaction is important which is given in NCERT, that is which one here? Reaction with HX. Reaction with HX. HCl, HBr, HI. Order of rate of reaction. Order of rate of reaction. Fastest will be which one? HI, then which one? HBr, and then which one? HCl. Here hardly you found that they said in NCERT that HCl is difficult to react. Which one is difficult to react here? HCl. So which one left here? Which one left here? Either HBr or either which one? HI, and most of the reaction you found which one here? HI. Most of the reaction you found which one here? HI. Now let's say this is ROR and this is reacting with HI, then this reaction may be either SN1 or maybe either which one? SN2. So always check first SN1. What I said, first always check which one? SN1. How to check SN1? If R1 or R2, R1 or R2, any one of them is 3 degree or resonance stabilized, then mode of the reaction will be SN1. Otherwise, in general, this will be which one? SN2. Otherwise, this will be in general which one? SN2. What I said here, if R or R1, if R or R1 or R2, any one of them is either 3 degree or resonance stabilized, then mode of the mechanism will be which one? SN1. Otherwise, this will be SN2. For example, if this is reacting with HI, tell me now, SN1 or SN2? SN1 or SN2? SN1 or SN2? SN1 or SN2? Which one? SN1. Why SN1? Because this side how much degree? So now this side bond we have to break because this side carbocation will be more stable or not. So product will be which one? This or not? Product will be this or not? If I said this one, now this is reacting with HI. Tell me now, SN1 or SN2? SN1 or SN2? SN2. So now SN2 will be from less crowded or more crowded side. SN2 will be from less crowded or more crowded side. SN2 will be from less crowded or more crowded side. Less crowded. So less crowded will be this bond or not. So in this case, product will be this one. Clear to everyone, yes or no? This is all about this chapter. This is all about this chapter. So bye bye all.
Good morning, everyone. Good morning, good morning, good morning. Can you hear my voice? Sweet voice. Am I audible? Okay. Good morning, good morning, good morning. Okay, so last class was completely numerical. This class will be completely theoretical because the chapters which we are going to discuss I think one chapter is capacitor. The another one is magnetism and matter. Capacitor and magnetism and matter. Okay? Bachapadi, in capacitor, since only we have only one lecture, so we will discuss this topic, dielectric. And here we will discuss the magnetic properties like paramagnetism, diamagnetism and ferromagnetism. My intention is to explain this thing because generally students face problem in this topic. But to understand this topic better in depth, we need some concept of dielectric. That's why I'm saying that this lecture is going to be completely theoretical. Is that okay with you? Or you want numerical of capacitor? We can go both ways. Okay. Theory, capacitor. चलो ठीक है. Let's start then. Coming to a dielectric. The general meaning of dielectric is insulator. There are two types of dielectric. One is polar dielectric. Another one is non-polar dielectric. Okay, so we will talk about their property in absence of external electric field. Now understand what happens in polar dielectric, bacha. In polar dielectric, the positive charge center and the negative charge center are separated. You can take an example like if you take the example of water. So if you say कि negative charge, since it is more electronegative, so you can say कि negative charge is somewhere near the oxygen, and the positive charge, it will be near the hydrogen, right? Microphone is muted. Am I audible? Bachawadi, can you hear me? Okay. Sri Lekha, please check your computer, sir. Not audible. Audible. Bacha, check your computer or whatever device you are using. Chalo, theek hai. Now, if I say negative and positives, just like center of mass, if you recall center of mass, two masses are there, then the center of mass lies somewhere in between, right? So similarly, like center of mass, if I define a term like center of charge, then I say कि positive and positive charge, its center of charge will be somewhere here. So center of negative charge is at oxygen, center of positive charge is somewhere in the middle. So negative and positive charge centers are separated. So negative and positive charge negative and positive charge centers are separated. Negative and positive charge centers are separated, due to which the molecule have inbuilt dipole moment. Molecule have inbuilt dipole moment. Okay? Because the negative and positive charge centers are separated, the molecule have inbuilt dipole moment. Okay? Now come to this one. Here, negative and positive charge centers coincides. Negative and positive charge centers coincides. Okay? Now, if they coincide, and I'll take an example of like CO2. Okay? So negative charge is here, negative charge is here. Here it is positive. Oxygen being more electronegative. Then negative and negative charge center will be right here. Correct? Negative and negative charge center will be right at the middle. Okay, so positive and negative charge center are coinciding, therefore dipole moment of the molecule will be 0. I think this thing you have gone through chemistry, polar molecule, non-polar molecule, correct? But this thing is valid in absence of external electric field. Okay, now if you go through, sir, if I take a sample, then dipole moment of the sample is 0. Now, what is sample? Sample meaning key collection of such molecule, right? Like H2O molecule is simply OHH, but H2O sample means a bucket of water, correct? A glass of water. So that is a sample. Means sample is nothing but trillions and trillions of the same molecule. Okay, Bachawadi? Now, it seems quite intuitive here. Sir, one molecule is having 0 dipole moment, then the sample will also have 0 dipole moment, because trillion multiplied with 0 will be 0 only. Correct? So this is quite intuitive here. It's intuitive ki one molecule 0, then sample will also have 0 dipole moment. But here, sir, one molecule was having some dipole moment, then why not the sample is having any dipole moment? Because if I multiply trillion with some number, then that number should be very large. So if one molecule is having some dipole moment, then sample should have very large dipole moment. Why it is coming out to be 0? Because dipole moment is a vector quantity. So it will be added according to vector addition, means direction is also considered. So due to random orientation of molecules, and why it happens? Thermal agitation. Due to temperature, due to thermal agitation, due to temperature, any temperature which is above 0 Kelvin, any temperature above 0 Kelvin, due to thermal agitation, the molecules, the orientation of the molecules will be quite random. That means, if I draw a diagram to make you understand, I will represent one molecule with the help of an arrow. Molecule I am representing with the help of an arrow means its dipole moment. Okay? So if it is H2O, then its dipole moment is like this, from oxygen to hydrogen in this. Okay? Then another molecule will be like this, another molecule will be like this, something like this. This is known as random direction. Okay? arrow is not clear. Let me draw for you. So although one molecule is having dipole moment, but if you take the addition, if you take the addition of all trillions and trillions of molecule, the vector addition of the dipole moment, it will come out to be 0. So that's why we are saying कि dipole moment, I hope you remember dipole moment, Q into D, dipole moment of the sample is 0. ठीक है, dipole moment of the sample is 0. ठीक है, here it is 0 because each molecule is having 0 dipole moments. Overall the sample will have 0 because any number multiplied with 0 is 0. ठीक है, so this is happening in absence of external electric field. In absence of external electric field. Now, what happens in presence of external electric field? Let's see. In presence of external electric field, beta, let's say it's a polar sample only. This one is polar. Here we are writing non-polar. Now, if I talk about molecule, it was already non-zero, so it will remain non-zero. Here the molecule was having 0 dipole moment. Now it will be also having non-zero. Means the negative and positive charge center will not coincide now in non-polar. It will not coincide. It will be separated. Why, sir? Because think like this. If negative and positive are at same place, negative and positive are at same place, and you place it in an electric field, then that electric field will apply a force on the positive charge and the negative charge. The force on the positive charge will be in the same direction of the electric field. Sorry. Force on the positive charge will be same direction of the electric field. Force on the negative charge will be opposite direction of electric field, due to which negative charge will be pulled left, positive charge will be pulled right in this diagram, and it will develop a dipole moment towards right. It will develop a dipole moment towards right. Towards right means it will develop a dipole moment in the same direction of field. In the same direction of field. Remember it. It will develop a dipole moment in the same direction of field. Okay? And it will happen with all the molecules. So sample dipole moment is also non-zero. Here it was already non-zero. But here sample was 0, but in presence of external field, means everything is non-zero. Now come to the polar first. Why, sir? Why it is non-zero now? What happened to that random orientation? I hope you are getting it. What happened to the random orientation, thermal agitation? So if you remember one topic, dipole placed in electric field. Dipole placed in electric field. When you place a dipole, let's say there is an electric field like this, beta. Recall that topic. If there is an electric field and if you place a dipole in this way, this is electric field, this is dipole, then a torque acts, which is given as torque equal to P cross E. It is given as torque equal to P cross E, and direction wise, E vector likes to rotate. E vector likes to rotate P vector along its own direction. Yes, E vector likes to rotate P vector along its own direction. Yes, yeah, correct. P cross E. Okay. So use this logic. Now, if you switch on an electric field here, all are P vector, all molecule has some P vector. Now, if you switch on an electric field, what will happen? All that electric field towards right side, let's say electric field is towards right side, it will start applying torque on each molecule. Applying torque on each molecule, due to which the molecule will align themselves in the direction of electric field, all the dipole moment P vector है ना will be in the direction of electric field, means the randomness will decrease, है ना, randomness will decrease and alignment will increase. So if there is a field along, let's say, right side, then the molecule will be like this, not completely right, somewhat little up and down, but more or less it will be, if you find now P sample, it will be है ना non-zero. है ना, P sample will be non-zero, and same diagram will be here. The process is different, I agree. Here P sample is non-zero because of the alignment of the inbuilt dipole. There was already some inbuilt dipole, है ना, and that was randomly oriented earlier in the absence of electric field, but now in the presence of electric field, they will be aligned in the direction of electric field due to the torque thing, okay? But now, in case of non-polar dielectric, है ना, same diagram, the net P vector, P sample will be parallel to electric field, but the reason behind that will be the stretching of the molecule due to the electric field. है ना? Here the reason is stretching of the molecule, here the reason is the torque applied by the electric field. I hope you understand till here. So final result is same. The underlying process is different. That's why generally in physics we don't talk about polar sample or non-polar sample, because ultimately the final result we are getting is same, right? Now understand what happens due to this. Bacha bani. Can I say there is a negative charge, there is a positive charge? Or if you want, I can draw a separate diagram. Negative, positive, negative, positive. It will appear like this. It will appear like this, okay? Now, if you see in the bulk, the positive, negative, positive, negative, positive, negative, it cancel out. But if you look at this edge here, and if you look at this boundary here, what is happening, bacha? There is a development of negative charge this side, positive charge this side. Okay, we call it induced charges. We call it induced charges. So if you place a dielectric in an electric field, the charges will get induced on the boundary, on the boundary, on the surface. Now, these induced charges will produce its own electric field from positive to negative. The induced charges will produce its own electric field from positive to negative. There was already field E naught. Let's call this field as E naught, external field E naught. So this is external field E naught, which is outside. Actually, it is everywhere. So E naught field is there external, which lead to this rearrangement of charge, distribution of charge, induction of charge, whatever you want to say, and due to which a field has been induced. Let's call it EIN, induced electric field, and that is in the opposite direction of the existing electric field. Induced electric field is in opposite direction of existing electric field, due to which what happened, beta? The net field inside the dielectric, is reduced. And what field you will write? You will write the field to be E naught minus E induced, but when you find, it will be something times of E naught, correct? Whatever value, that value can be written as something of E naught, right? So it becomes E naught by K, where K is known as dielectric constant. K is known as dielectric constant. K is also known as a relative permittivity. It is also known as relative permittivity. So, in short, if you place a dielectric in an electric field, then charges will get induced on the surfaces on the boundary, due to which induced electric field will be developed, and hence the net electric field decreases because the induced electric field is in opposite direction of the existing electric field, and the net electric field decreases. So far so good. I hope the story is clear till here. You just listen today, just listen. समझ में आएगा? चलें आगे. ठीक है, now come to the topic magnetic properties, because this thing will be required in magnetic properties. Magnetic properties of material. There are three types of magnetic properties. One is diamagnetism, another one is paramagnetism, and next one is ferromagnetism. Based on which type of property is being exhibited by, is shown by any material, we call the material as diamagnetic material, paramagnetic material, or simply diamagnet, paramagnet, and ferromagnet or ferromagnetic material. Now, ferromagnetic material or ferromagnetism we have seen since childhood. You have seen one means coin, iron coin, being strongly attracted by a magnet. Okay? That is known as ferromagnetism. If a material is strongly attracted by a magnet, that is the behavior of a ferromagnetic substance. Now, what is paramagnetic substance? What is diamagnetic substance? We will discuss. You have seen them, like aluminum we have seen, copper we have seen, water we have seen. Okay? So these are also some kind, either paramagnetic or diamagnetic, but since their interaction with the magnet is so weak, in that we have to do that experiment very carefully. Like, sir, if I take a magnet and aluminum, if I take a magnet and a copper, sir, magnet doesn't attract aluminum. Sir, magnet doesn't attract or repel copper. No. Magnet does attract or repel copper, but for that, it will not be, you can't be casual and do the experiment and observe it. If you want to observe that attraction, because that attraction and repulsion is so weak, if you do the experiment casually, while playing I have not seen. No, you will not see. You will not feel it. You have to be very, 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 very careful. So, when you do the experiment carefully, you will find magnet doing some interaction with aluminum, copper, water, etc. Okay? Chalo. So let's study what happens, what is diamagnetism and paramagnetism. First of all, we will discuss these two, and we will find ferromagnetism is nothing but extreme case of paramagnetism, amplified case of paramagnetism, hyper case of paramagnetism. Okay? Chalo. Start at the atomic level. Bachawadi, see. Just like I compared polar and non-polar, I'm going to compare diamagnetic and paramagnetic. At atomic level, these will have paired electrons. And these are going to have unpaired electrons. Diamagnetic substances at atomic level, their atoms are going to have paired electrons. Share QR code. Yeah, okay, bacha, no problem. I will share the QR code. Okay, so diamagnetic material, their atoms will have paired electron. Paramagnetic material, their atoms will have unpaired electrons. Okay. Now, Bacha buddy, again, for a better understanding, let's discuss something like, if you recall, ki, let's say an electron is going anti-clockwise. An electron is going anti-clockwise, then we can say ki it constitute a current. Electron going anti-clockwise, omega is anti-clockwise, it means ki there is a current clockwise. And similarly, if an electron is going clockwise, it means ki there is a current anti-clockwise. Right? Can I say like that? So a charge going in a circle is equivalent to current in a loop. Diane, para same and that way, it is same thing, but we may be exploring the different aspect of that. In chemistry, you might have discussed some different property. Here we will discuss some other aspect. But everything is same. Okay, understand here. So electron going anti-clockwise, it makes a current clockwise. Here electron going clockwise, it means the current is anti-clockwise, right? Now we know in physics that a current carrying coil has a magnetic dipole moment which is represented with m vector or mu vector, whatever you use. M vector or mu vector, which is defined as NIA. It is defined as NIA. Okay? So a charge going in a circle is equivalent to current carrying coil. A current carrying coil has magnetic dipole moment, which we discussed right now. It has a magnetic dipole moment. Oh, sorry, we discussed electric dipole moment. Here we are talking about magnetic dipole moment. So if you find ki sir I is how much, so I is q omega by 2 pi. A current carrying, a charge going in a circle make a current q omega by 2 pi. Then m or mu we can define as I into a. Let's say the radius is r. So it becomes half q omega r square. Okay? So remember this point. Key. A charge going in a circle, it has a magnetic dipole moment. Charge going in a circle has a magnetic dipole moment, either represented with capital M or represented with mu, and its formula is half q omega r square. Q we will take E, and radius and omega of the electron. Okay, now come to this paired electron and unpaired electron. Now one thing, let me make it very clear. Whatever we are going to discuss from now is with the help of classical physics. Okay? And classical physics is not a correct tool to understand the property of diamagnetism and paramagnetism, all these. The magnetic properties can be only understood with the help of, it can be described with the help of quantum mechanics, which is beyond our level of understanding right now. Okay? So that's why, but classical physics can help you in visualizing it, although it is not a correct interpretation, but at least it will help you in visualizing it. So whatever we are going to discuss from now will be helpful in visualizing. It doesn't mean it is going to be correct. Okay? So please focus. Now, you know that electron has orbital motion. Electron also has some spin motion, right? So, but in classical physics, we consider only orbital because that we can visualize. The spin thing we don't consider in classical physics. Okay? Now understand. So we know that paired electron always paired with opposite spin. Opposite spin. Now, as I said, a spin is a different thing, but in classical physics, you can understand like a spin means opposite spin means that one electron is going anti-clockwise, another electron is going clockwise. One electron is going anti-clockwise, another electron is going clockwise. Just opposite spin means this thing in classical physics, just ऐसा मान लेते हैं, है ना, मान लेते हैं. Okay, now so if one electron is going anti-clockwise, so its current will be clockwise, it will have m vector in this direction. Please understand, it will have m vector inward, and this one will have m vector outward. If omega and r remain same, है ना, then what will happen, bacha? Their m vector will be equal and opposite. Their m vector will be equal and opposite. So I can say due to paired electron, again I will tell you, pairing always happen with opposite spin. Pairing always happen with opposite spin. Due to the opposite spin, their m vector will get cancelled out. Okay, but here we have unpaired electron. So here atom or sample m vector will be non-zero due to the core one will get cancelled. Please understand. Unpaired electron, that means the outermost electron, the valence electrons are going to be unpaired, right? If I talk about core electrons, like if electronic configuration goes like this, K1s2, 2s2, 2p6, something like this, 3s2, 3p3. Then this 3p3, they are only unpaired electrons. Remaining the core, 1s2, 2s2, 2p6, they are paired. Are you getting it? So here all are paired except the last few electrons, maybe 1, maybe 2, maybe 3. I hope you are getting it. Okay? So due to those last unpaired electrons, the atom or sample is going to have some magnetic dipole moment. So you can consider it like a non-polar molecule. If you recall, if you connect with the electrostat, this is similar to non-polar, and this one is similar to polar. Here the inbuilt dipole moment is there. Here inbuilt dipole moment is 0, and we are talking in absence of external magnetic field. But if I talk about what about M sample, it is 0. M sample is 0. It looks quite obvious here. Again, it is quite obvious here. Okay? Because sir, one atom is having 0, then entire sample will also have 0, sir. Trillions time 0, again 0, same logic. But here, sir, one atom or one molecule was having some dipole moment, but you are saying trillions of atoms combined dipole moment is 0. Why? Again the same logic. Due to random orientation. And who is responsible for random orientation? Thermal agitation. Thermal agitation. Okay? Now let's discuss what will happen in presence of external field. This is the story in absence of external field. I hope it is clear till here, beta. In diamagnetic material, that means all electrons are paired. Pairing always happen with opposite spin, due to which electrons will always have equal and opposite m vector, and the net m vector of the atom or molecule will become 0. Okay? When atom or molecule m vector becomes 0, we say it is diamagnetic. Okay? In paramagnetic, although the core of the atom will be still paired, but last valence electron, few valence electron will be unpaired, and due to those unpaired electrons, there will be some magnetic dipole moment. Okay? But sample, it will be overall 0 because of thermal agitation. Now let's discuss what will happen in presence of external field. In presence of external field, if I talk about the paramagnetic material, everything, paramagnetic, diamagnetic, whatever, M atom or molecule, it is non-zero. M sample, it is non-zero. Okay? Everything it is non-zero. This was already non-zero. So it is still non-zero. Okay, no problem. Why this one? If you remember, sir, M sample was 0. Thermal agitation, why it is non-zero? Again, due to the alignment thing. Why it is non-zero? Due to due to torque. Due to torque applied by external magnetic field. Hanan, according to the formula, torque equal to M cross P. Although the alignment will not be perfect, there will be some alignment, there will be some randomness. If you want to get more alignment, then you have to increase the magnetic field or decrease the temperature. Increase the magnetic field or decrease the temperature. Here, sir, why this atom? Because here, to okay, I can understand alignment and all happened. Here, to if you remember, sir, paired electrons, then what happened? Suddenly it become unpaired. Why the atom is now having non-zero dipole moment? Why the atom is now having non-zero dipole moment? Hana? Because pairing to still it is there, sir. Now what happens, beta? When you switch on the magnetic field, understand, the magnetic field was not there. Then suddenly you brought the material inside the magnetic field. That means if you switch on the magnetic field, let's say it become 10 Tesla. But earlier it was 0 Tesla only, na? Then suddenly it become 10 Tesla. Then in that short duration of time, magnetic field changed very fast. Hai. In short duration of time, magnetic field changed very fast. One second. I have to change the setting. Okay? Magnetic field changed very fast. So due to Lenz's law, induced current will be seen here. Come on, yaar. Just 1 minute. We have to change the setting. Okay, chalo.
Okay. Done. Okay.
Hello, hello. Can you hear me now? Yes, okay. Thank you, thank you, thank you. Yes, sir. चलिए sir. Okay, sir. Okay, so we will resume. चले कंटिन्यू करते हैं. Okay, I will repeat. I was saying, when you switch on the magnetic field, let's say it changed from 0 Tesla to 10 Tesla in almost no time. So for that short duration, some electric field will be present here. Some induced electric field will be present here. Due to that induced electric field, which is appearing for a very short interval of time, a kind of impulsive torque will act. Kind of impulsive torque will act, which will change the omega of these two electrons. Although they are paired, but the omega will be changed. Again, if you want, I can go in depth here, ki sir, which one omega will increase, which one will decrease. We can think that will depend on in which direction you have switched on the field. If the field is switched on like this, inward, inward magnetic field is there, it is switched on. So this omega will decrease, and this omega will increase. Think in manner of induced electric field, in which direction induced electric field will appear and in which direction it will apply torque, you will get it, but that is not of our use. Just understand that one of the omega will decrease, one of the omega will increase. I'm talking about diamagnetic substance. Come on, I'm talking about diamagnetic substance. I know there was a pause, but I hope you are able to recall this. In absence of magnetic field, the omega was same and their m vector was equal and opposite, and it was getting cancelled out in absence of magnetic field. Now in presence of magnetic field, one of the omega will increase, another omega will decrease. So although they are paired right now also, but since their omegas are different, their m vector will be different and they will not get cancelled out completely. There will be some residual m vector left. I hope you understand. And if means that m vector decreases, which is in the same direction of B, that m vector increases, which is in opposite direction of B. So if I now ask you, bacha, ki net m1 and m2. So net m vector will be m2 minus m1, and net m vector of the atom, net m vector of the atom is going to be anti-parallel of the external field. Please understand, it is going to be anti-parallel of the external field. Okay, this is what we find based on Lenz's law. Again, I will tell you this is not a correct way to explain, but we can get a feel using this Lenz's law. That's why we are explaining like this. Otherwise, this is not a correct way to explain. The correct way lies in quantum mechanics. Okay. So here m atom is non-zero, so m sample is non-zero. But one thing we got here, ki here m vector, m sample is anti-parallel to b vector, and here m sample which you will get is going to be parallel to b vector. Why parallel to b vector? Because b vector will rotate m vector along its own direction, and here m vector is coming opposite to b vector as discussed in previous slide, right? According to Lenz's law. So if I draw the diagram, here it will be something like this. Little bit randomness will be there. Little bit randomness is there, means it is oscillating something like this. You can understand it is still oscillating like this. But anytime if you find m sample, you will get m sample in the right direction. Why? Because the external field which has been applied, the external field which we have applied here, bacha badi, let's call it B naught. The external field is right side. So the M sample, if you take the vector addition of all these vectors, M sample will be also right side. That's why we are saying M sample is directly is parallel to B, and this right side has been done due to torque applied by B naught. I hope it is clear. In paramagnetic, it is same as polar molecule. Here what happens, here M sample, it is in opposite direction. It is in opposite direction. That means if B vector is right side, then M sample, you can see it is in left side. M sample is left side. So that's why we say that paramagnetic material gets magnetized in the same direction and diamagnetic material is magnetized in opposite direction. Now, one term I have used, material is magnetized. What do we mean by material is magnetized? You think like this, you take a magnet. Understand like this. You take a coin. This is a coin, iron coin, ferromagnetic coin. Now, if you take another coin and try to bring in contact with the other coin, do you think the first coin will attract the second coin? No. First coin will not attract the second coin. Means it is not magnetized. It is not behaving like a magnet. It is not magnetized. So not magnetized meaning, if M sample is 0, it means unmagnetized. So right now the M sample of this coin is 0. That's why it is unmagnetized. It is not able to attract any ferromagnetic substance. But if M sample is non-zero, then we say it is magnetized. So if a material is behaving like a magnet, it is able to attract another substance, or it is showing a repulsion or attraction to the other magnet, that means that one has been magnetized. That one has been magnetized. An unmagnetized thing will not show any response, or it will not attract or repel any other material. A magnetized material can only attract or can show response to the magnetic field. Okay? So that's why an iron coin is not able to attract another iron coin. Okay? But M sample becomes non-zero. Understand? M sample becomes non-zero in presence of external magnetic field. In presence of external magnetic field, M sample becomes non-zero. In absence, M sample is always 0, whether it is dia, para or ferro. M sample will be always 0 in absence of external magnetic field. In presence, M sample will become non-zero. That's why when you bring a magnet, whatever pole, doesn't matter. When you bring a magnet and make this coin attracted to the magnet. Now, magnet, first coin. Now, if you attach a second coin here, now the second coin will be attached to the first coin. That means now the first coin is behaving like a magnet. The second coin is not attached to the magnet. The second coin is attached to the first coin. That means the first coin is now behaving like a magnet. Now the first coin is magnetized. How it is magnetized? Because now it is present in the magnetic field of the magnet. Now it is present in the magnetic field of a magnet. And when, like, this magnet will create a magnetic field, this magnet will create a magnetic field, and due to this B vector, here now M sample will become non-zero. When M sample will become non-zero, now it is behaving like magnets. Simple. I hope this point is clear. Take it, bacha badi? Okay. Now, how strongly anything has been magnetized? We define it with the term intensity of magnetization. Intensity of magnetization, it is M sample by volume. Intensity means how strongly a material has been magnetized. Like, if I give you an example, if I take a iron and if I take a copper and I place it both in the same magnetic field. Means you take a magnet, you take iron coin, you take a copper coin. Which one will get magnetized more? Come on, tell me, then only I can understand you are getting me or not. If you take an iron coin, if you take a copper coin, which one will be strongly magnetized? Everything is same, dimension is same, everything is same. If you take an iron coin, if you take a copper coin, you place both in a same magnetic field, which will behave like a strong magnet. Iron or copper? Aluminium. If you are not sure in iron, copper, take iron and aluminium. Do you think a magnet can attract aluminium coin that much strongly as magnet can attract iron coin? Come on. A magnet can attract aluminium coin strongly, or a magnet can attract iron coin strongly? Obviously, a magnet will attract, yes, correct. Magnet will attract iron coin strongly, right? Magnet will attract iron coin strongly. See, understand. M sample by volume, that is the density of M sample. Higher amount of M sample meaning it is magnetized strongly. Higher amount of M sample meaning it is magnetized strongly. Okay? But instead of talking about M sample, we talk about M sample by volume because we are talking about the material, we are not talking about the object. Like if I ask you, aluminium is heavy. So you can tell me, aluminium is heavy or iron is heavy as a material? Water is heavy as a material. Water is heavy or iron is heavy? What do you think? As a material, water is heavy or iron is heavy? This much, so you can tell me. Come on, reply. As a material, water is heavy or iron is heavy? Obviously, as a material, iron is heavier. That's why when you drop a iron object in a water, it sinks, right? But understand, bacha badi. If I take 10 kg of water and 1 kg of iron, 10 kg of water, bucket of water, 10 kg water, and 1 kg of iron, then 10 kg of water is heavy. So understand, we are not talking about the sample, we are talking about the material. Material, which one is heavy? So that's why we will not talk about the mass there. We will not talk about mass. If you're talking about the material, we will talk about the density. Equal, means equal volume we take, equal amount we take, then which one is having more mass, right? So that's what I'm saying, bacha. So when you talk about the material, you talk about the density. Similarly, when you are comparing iron and copper, iron or aluminium, iron or bismuth, which one can be more magnetized in a magnetic field? So we will not talk about the M sample because bigger sample will mean more M sample. Okay? So smaller M sample means, a smaller sample means less amount of M sample. That's why we are not talking about M sample, we are talking about M sample by volume. So intensity of magnetization tells us how strongly this coin has been magnetized. It means I talks about this thing, how strongly a coin has been magnetized, a material has been magnetized. Then the second term is magnetic field or intensity of magnetizing field, or simply they say in some books simply they say magnetic intensity or magnetizing field intensity of magnetizing field, whatever. We define it like H equal to B naught by mu naught. Intensity of magnetizing field means it tells us about this magnet, how strong this B vector, which is responsible for the magnetization of this coin, which is responsible for magnetization of this coin, how strong this B is. So H tells us about the cause, the magnetic field which is responsible for the magnetization. I talks about the effect, the coin, how strongly a material is magnetized. Understand in this, you may be able to understand this better. H talks about this V naught, how strong this field is, how strong the magnetizing field is, the one which is responsible for the magnetization, how strong that field is. Okay. And I talks about this one, this sample, how strongly this is magnetized. So this is B naught is the cause. Here, whatever it is happening, M sample, B naught is the cause, M sample is the effect. So H talks about the cause, B naught by mu naught, and M sample by volume, it is I, both have same unit, which is ampere per meter. Next term is magnetic susceptibility. Psi m is written as I by H. I by H. It tells us about the degree of ease of magnetization. Degree of ease of magnetization. Degree of ease of magnetization. Please understand, everyone. Consider this case. Okay, let's say there is in the same magnet, same place, if you take one iron coin and another one you take, let's say you are not getting it, then you take, say, wood. No, or aluminium or copper, which is not a ferromagnetic. Okay? Or anything. One is iron and another is any just, ferromagnetic substance are only, major ferromagnetic substance are iron, cobalt, nickel. Galvatinium is also there, but simple are iron, cobalt, nickel, or their alloy. Okay, aluminium and copper are not ferromagnetic. Now you tell me, if you keep both material in the same magnetic field, in same magnetic field, in vicinity of the same magnet, tell me which one will behave like a stronger magnet, iron or aluminium? The same question I asked. Which one will behave like a stronger magnet? Come on, Vachavadi, tell me first. Okay. Okay. So I was saying if you place iron or aluminum or copper, then iron will get more magnetized. Its M sample will be much higher as compared to the M sample of the aluminum and copper. So that means for the same, here H is same because same magnet, here H is also same because same magnet. But here I value is much larger than here I value. Okay? So for the same value of H, iron is something. एक second. Please don't disturb it. For the same value of H, it is iron which is having a higher value of I as compared to aluminum and copper. That means it is easier to magnetize an iron. It is easier to magnetize an iron as compared to magnetizing aluminum or copper. Okay? So magnetic susceptibility value is high. If magnetic susceptibility value is high, it simply means that material can be easily magnetized in a magnetic field. Okay? Bachapadi, clear till here? Tell me first. The next term is Permeability is defined as net filled divided by H. It is defined as net filled divided by H. Just like in dielectric, understand this. Understand it better. Due to this thing, what will happen here? In diamagnetic and paramagnetic, if you place both in external field B naught, due to opposite direction of M vector, here induced field is opposite direction of external, here induced field is the same direction of external, please understand. If this is B naught external, so here B induced will be opposite direction because the M sample is opposite direction. Here also B naught is right side, but here B induced will be in the same direction. So net field, it reduces here. Here net field increases. Net field reduces in diamagnetic material. Here net field increases. Here net field increases. Okay. So I can write this B naught plus B induced by H. But B naught, if you remember, means H you can write like this. B naught by mu naught or B net by mu. If you are defining in vacuum, then you will take the field in vacuum divided by permeability of the vacuum. And if you're defining in a material, so in a material, understand, if you take this point by the outside point, vacuum, so here the net field is only B naught. But if you take a point in the material, then in the material B induced will be also there. So net field will be different from B naught. Net field will be different from B naught. Okay, so in vacuum it is B naught. In material it may be less than B naught. It may be more than B naught. It will be less than B naught. In case of diamagnetic, it will be more than B naught. In case of paramagnetic. So you can write mu naught into H, just like B naught is written mu naught into H. B induced we can write mu naught into I. Or you can just remember it, mu naught 1 plus I by H. Mu can be written as mu naught 1 plus psi, susceptibility. Then we define a term relative permeability, which is mu by mu naught, which is 1 plus susceptibility. Remember these 5 terms, Bacha. Again, I will go through these 5 terms. First one is intensity of magnetization. It talks about the material which is getting magnetized. If a material is getting strongly magnetized, it means its I value is large. Like for a ferromagnetic material, I value is very large because ferromagnetic material gets strongly magnetized in a magnetic field. So I value for a ferromagnetic material is very large. Okay. Then the next term is magnetic intensity. It tells us about how strong field we are using for magnetization. That means it talks about the cause. It talks about the external field. How strong external field is there, which is responsible for the magnetization. Okay. Magnetic susceptibility is ratio of these 2 terms, which simply means how easily a material can be magnetized. Obviously, for equal value of H, if 2 material we take, iron and aluminum, for equal value of H, the one which will be producing higher value of I, for equal value of H, the one which will be producing higher value of I, that means it is easier to magnetize that material. Like iron will produce higher value of I for same value of H, That means susceptibility of iron is more as compared to aluminum and copper or any other substance, right? Okay. Permeability, just remember the formula. If you're not getting it, permeability means mu naught into 1 plus susceptibility, and relative permeability means formula is 1 plus susceptibility. Now, what are the different properties? Of the diamagnetic substance? The first one is they get feebly magnetized. Now everything we know, now we are summarizing. Last 5-10 minutes, please. Feebly magnetized in opposite direction of external magnetic field. Feebly magnetized in opposite direction of external magnetic field. What is the meaning of this? Feebly means weakly. Weakly means the I value will be very small. Weakly means I value will be very small. Opposite direction of external magnetic field means its M sample will be anti-parallel of P. So feebly meaning I value is feebly means weakly, meaning I value is very less, and opposite direction means M vector is anti-parallel to B vector. M vector is anti-parallel to B vector. The second point, they have a tendency to move from high to low magnetic field region. They have a tendency to move from high to low magnetic field region. That's why, if you do some experiment like that is, they will be weakly repelled by magnet. What do you do? You take a string, you take any diamagnetic substance, you take any diamagnetic substance here, and hang it. Don't place it on the ground. Hang it with the help of a light, very thin string. Then you take a magnet, and bring this magnet very close to this material, very close. You'll find this material is getting repelled by the magnet. You'll find the material getting repelled by the magnet. Why? Because if there is a magnet here, then here strong magnetic field, when you go away from the magnetic field will decrease. So near the magnet, high magnetic field, here low magnetic field. That means a variable magnetic field. So any diamagnetic substance will have a tendency to go from high magnetic field to low magnetic field. That's why it is going away from the magnet, because it wants to go from high to low magnetic field. And that's why we say that diamagnetic substances are repelled by the magnet. Okay? So the diamagnetic substances will be repelled by the magnet. Okay, bacha? Weakly repelled by the magnet. Another thing you can find during experiment is if you take a bar magnet and you take a diamagnetic substance in a powder form, powder form, and sprinkle over this bar magnet and shake it a little bit, you will find they are making a heap like this. The diamagnetic substances will make a heap like this because at pole the field is strong, and in the middle you will find field to be weak. That's why they will try to accumulate near the center, because at the center the field is less. Same logic. If you take two magnets and place a diamagnetic needle here, so you'll find the needle will align perpendicular. I can show in 3D something like this. It will align perpendicular means I can show like this, it will align something like this. It will align something like this. Please understand better. Two magnets are there, then it will align perpendicular to the magnet. It will align perpendicular to the magnet. In 3D, don't visualize, just if I say like this, then it will align like this. It will align like this. These are the story of diamagnetic material. It will be like this all these train, maglev train, magnetic levitation. The diamagnetic material can show magnetic levitation because it will be repelled by the magnet. ठीक है, तो all these maglev train है ना, these are based on property of diamagnetism. That means what I'm trying to say, कि you can hang a particle, a diamagnetic particle. Let's say this is a diamagnetic particle. You take a magnet, either north pole, south pole, doesn't matter. So you can stop this object to fall. है ना? You can stop this object from falling because this material will repel. The magnet will repel the diamagnetic substance which can. So that means this magnet will apply a magnetic force upward which can counter its weight. So we can magnetically levitate any object. Means we can hang any object in here. We can hang any diamagnetic object in here. Okay? Now, third point we say, okay, the field lines are repelled by this. Field lines, see, the field lines are weakly repelled by these materials, something like this. Something like this. Why? Because understand, here we know the field is going to be less than B naught. Outside point, the field is B naught. Please understand, outside point, the field is B naught. Inside point, the field is something less than B naught. Something less than B naught. Then, here field is B naught, here field is less than B naught. So here number of field lines should be more, here the number of field lines should be less. It's common sense, hai na? Where high magnetic field, the density should be more. Low magnetic field, density should be less. Okay? So here it is B naught, here it is less than B naught. That's why it is giving an illusion, giving a feeling that the magnetic field lines have been repelled. It's just a common physics, right? Chalo, next. Now, since it's weakly magnetized and in opposite direction, the susceptibility is negative, but it will be less negative. Less negative means, example, psi value will be, let's say, minus 0.05. Minus 0.05. It will be negative, but very less value. Hana? Remember, the susceptibility value can only go from उल्टा लिख दिया. It can only go till -1, and the -1 value is only for superconductor. Susceptibility value is approximately -1 for superconductors. That means superconductors are perfect diamagnetic material. The superconductors are perfect diamagnetic material. Acha, understand? Okay. Mu will be mu naught, 1 plus susceptibility, we know the formula, and susceptibility is negative, so 1 minus something. It means mu will be less than mu naught. Mu will be less than mu naught, and 6th point ki mu r will be less than 1. Mu will be less than mu naught, and mu r will be less than 1. Now, here lies the meaning of permeability. Permeability means ki how many field lines are able to permeate through a medium, means penetrate through a medium. Means equal thickness in vacuum. If you see in vacuum, 1, 2, 3, 4, 5, 6 lines were able to penetrate this much thickness in the vacuum. But in the same thickness here material, how much field lines are penetrating, going, permeating? 1, 2, 3, 4 only. In the same thickness here only 4, here 6, here 4, here 6. It means what? Here ability to permeate through a medium, pass through a medium is less. ठीक है. That's why the diamagnetic material permeability, the ability to permeate through a medium, है ना. Diamagnetic material permeability is less than permeability of vacuum. This is the meaning. Number of field lines passing through the diamagnetic material will be less as compared to the number of magnetic field lines passing through the vacuum in the same width. ठीक है. Mu r is less than 1. Okay, ठीक है. One important point is susceptibility is independent of temperature. Susceptibility is independent of temperature. Acha, for superconductor, if susceptibility is -1, then 1 minus 1 is 0. So for superconductor, mu is 0. है ना? For superconductor, mu is 0. What is the meaning of mu 0? That means the ability of magnetic field lines to permeate through the superconductor is 0. Means no magnetic field lines will permeate through the superconductor. Please understand. So if it is a superconductor and the magnetic field lines are like this, then all magnetic field lines will be repelled like this beta. And inside the superconductor, net magnetic field will be always 0. That's why the superconductor is also used for magnetostatic shielding. Magnetostatic shielding. So these are few important points regarding diamagnetism. In paramagnetism, I will go first. We will do the reverse just. Like first point will be it is feebly magnetized in same direction. In paramagnetism, better it will be feebly magnetized in same direction of external magnetic field. It has a tendency to move from low to high magnetic field region. That's why it is weakly attracted by magnet. It is weakly attracted by magnet. That means if you take a paramagnetic material in powder form and sprinkle it, it will form a shape like this. Means more will accumulate at the pole and less will be at the center. And here if you do this experiment, take two poles, something like this, and hang a paramagnetic material, then paramagnetic material will be hanging like this. The magnetic field lines will be, it will be attracted inside. Magnetic field lines will be attracted inside. So when it will be attracted inside, so obviously permeability of the paramagnetic will be also more. So B will be more than B naught. B will be more than B naught. So more number of magnetic field lines will go. Means magnetic field lines will be attracted. Due to which mu will be more than mu naught. Means susceptibility is positive. Susceptibility is positive. Susceptibility is positive, but it will be less positive. Example, plus 0.05. Okay. Here mu will be more than mu naught. Mu1 will be more than 1. And the seventh point will be susceptibility is inversely proportional to temperature. Remove the proportionality sign. It will be C by T, which is known as Curie's constant. C is known as Curie's constant. Means when you increase the temperature, susceptibility will decrease. Obviously, when you increase the temperature, susceptibility should decrease. Because when you increase the temperature, randomness will increase. And when randomness will increase, then M sample will decrease. When randomness will increase, M sample will decrease, I will decrease. If I value is decreasing, then susceptibility is I by H. Susceptibility will also decrease. Okay? In ferromagnetic substance, the same answer of paramagnetic, only thing, everything will be amplified. Amplified meaning This will be same direction, but instead of saying feebly magnetized, we will say it is strongly magnetized. Tendency to move from, yes, tendency, but a strong tendency. Okay, that's why if you take a magnet, if you take a iron coin and a magnet and hold it like this, the iron coin will stick to the magnet, means it will fly. Hana, means it will overcome its weight. So the magnetic force is so large, it is able to overcome the weight of the iron coin, and iron coin flies and stick to the magnet, right? But this will not happen with the aluminum. This will not happen with aluminum. This will not happen with copper or something. Why? Because their magnetism is so small, it is not able. The magnetic force is not able to attract the aluminum coin, because aluminum is paramagnetic. I hope you understand this point. ठीक है बच्चा बड़ी? So they are strongly attracted by magnet. है ना? Strongly attracted by magnet. Magnetic field lines will be crowded. Magnetic field lines will be crowded. And here what will happen? Here it will be much greater than, and value will be like 500. है ना? It will be large positive value. It will be large positive value. Okay. Mu will be much greater than mu naught. Mu r will be much greater than 1. Remember these points. Okay. Point you can see from the notes or from any book also. Okay, you can go through it. Main idea was to give you the basic of the paramagnetism, diamagnetism, how it arises, what is the, why it arises. I know it is little bit tough for you. Okay. But please go through the lectures. I think it will be available on YouTube. Please go through it again and again, 1-2 times. ठीक है बच्चा बाड़ी? Thank you for your time and patience. ठीक है? We will meet soon. चलो, टाटा, bye bye.